Now we're going to talk about zeros of polynomial functions and what happens to the graph at those zeros. Okay, some different words. We can call it zeros, roots, x-intercepts, or solutions. When we're solving a polynomial function, when y equals 0, we're trying to find what the values of x are, where it either touches or crosses the x-axis. So in this little squiggly graph, which we don't know the equation of, but that doesn't matter, this crosses the x-axis at 4 places. And there's 4 little yellow marks. So those would be the zeros, the roots, the x-intercepts, the solutions, whatever you want to call them. Okay, so let's look at an example. F of x equals x cubed plus 3x squared minus x minus 3. That's not this graph, by the way. So what we want to do is factor it, set each factor equal to 0, and then solve. The only way we can factor this, because there's no common factor all the way through, is to regroup. So I'm going to regroup the first two and regroup the second two. Out of the first two terms, I'm going to take out an x squared, so I'll have x plus 3 left over. And out of the second one, I'm going to take out a negative 1, and I have x plus 3 left over. So now when I put my x squared minus 1 together, times x plus 3, that's equal to 0. And my x squared minus 1 is going to be x plus 1 times x minus 1, and then times x plus 3 equals 0. So I know that my 3 roots or solutions are negative 1, 1, and negative 3. If I wanted to write them as coordinates, then it'd be negative 1, 0, 1, 0, negative 3, 0. Okay, go take a look at checkpoint number 5 and come back. All right, here we are back. Example 6. We have f of x equals negative x to the 4th plus 4x cubed minus 4x squared. And I want to set that equal to 0, so I'm just going to get rid of that f of x. All right, now, I don't like having my leading coefficient negative, that's just me, so I am going to multiply through by negative 1. And now I'm going to take out an x squared term, factor out x squared. So I have x squared times x squared minus 4x plus 4. I can now factor this, and that is a perfect square. So I'll have x squared times x minus 2 squared equals 0. So that means x is 0 and x is 2. In a few minutes you're going to find out something special about this, since they're both squared factors. They're going to have something special going on with them. Okay, so go ahead and do your checkpoint number 6 and factor that one. Okay, now we're going to talk about multiplicities of zeros. Here's two graphs. This graph has factors x plus 1, x minus 1, x plus 3, because the roots are negative 3, negative 1, and 1. This one has x squared times x minus 2 squared. Notice how the graphs behave. One graph is continuous, goes down and then goes back up. The blue one on the right kind of has a little bounce going on there. Okay? Well, each one of the factors for the left-hand graph has an exponent of 1. And you can see there's the 3 points. And in the first one, where x equals negative 3, the graph is going from negative to positive. It passes through the x-axis. Then it comes back down, it passes through the x-axis again, going the opposite direction, and then it passes through the x-axis again. Okay, it goes through. On the right-hand graph, it touches and turns. We have, the through is an odd power. We have 1, 1, and 1 for each one of the factors. Here we have exponents of 2 and 2. And they're each even. Now we're not talking about the entire function being even, we're talking about individual factors being odd or even. And both of those are even. And if you notice, at x equals 0, it touches the x-axis. Whoops. Come back. Well, we'll go on. Touches the x-axis and bounces back. All right. So multiplicities and x-intercepts again. Here we have it. At zeros of even multiplicities, the graph touches the x-axis and turns around. In other words, it bounces. Is a good way of putting it. Bounces and comes back like it hits a wall and bounces off of the wall. like that. And at zeros of odd multiplicities, the graph crosses the x-axis, or it goes through the x-axis. Now, we're not talking about the entire equation or the entire polynomial being odd or even. We're talking about each individual factor. If it is a multiplicity of an odd number, it's going to go through the graph. If it's even, it's going to bounce off the graph. The bigger the number, the more flattened out the graph gets at that point. So if you would put in your graphing calculator something to the fourth power, y equals x to the fourth power, it's going to look kind of like a parabola that's somebody kind of sat on the bottom of it. Okay, like that. Okay. So an example. Here we want, example number 5, we want to first find 7, we want to find the zeros. We want to determine what the multiplicity of each is, and then state whether it bounces or goes through the graph. So here's our equation. Okay? I'm going to set it equal to 0. And now I'm going to multiply through by 1/2, because I multiply both sides by 1/2. I don't change anything except to get rid of the 1/2. And this means that I have x equals -1 or x equals 3/2. But I have to take a look and say, what's going to happen to that graph? I'm not actually going to plot points on this graph, but I just want to know, just like when we were talking about what's the end behavior, what is it looking like? What is it kind of doing? Okay? So with the first one, x equals -1, that's a multiplicity of 1, which means it's going to go through the graph. And with the second one, it's a multiplicity of 2, so at 3/2, it's not going to go through the graph, it's going to bounce off of the graph and turn around and go back. Crosses, bounces. All right, here's what this graph looks like. And you can see at x equals -1, we go through the graph. And then at x equals 3/2, it bounces. It comes down, hits that x equals 3/2, and bounces back, going back the same direction. So do your checkpoint number 7. And that's it for this one, friends. See you in class.